how TypeScript knows what is the type of a variable in every single line of code, and how can you tell if a variable has the type you expect it to have, how you can narrow down types to more specific ones. In this episode of Too Long to Read TypeScript, we will go back to the roots of the language, and we will talk about complex behaviors like coercion, and we will talk about truthiness and how to write if statements. Okay, this sounds a little bit basic, but trust me, all these topics have troubled a lot of JavaScript developers for years. We will review this strange behavior, and I will show you how TypeScript can help you deal with it. It's another interesting episode, and I'm glad you're back. Hello friends, it's Nikos here, and welcome to another episode of Too Long to Read TypeScript. In this series, we try to learn the language step by step, and we try to explain the most important concepts behind the language features. This time, we are going to search for the truth. Before we begin, let's start with a coding challenge. So here we have a function getWidth, which accepts this width parameter, which can be a string or a number, and it checks basically if it's a number, it adds the suffix px, which stands for pixels, and if it's not a number, it just returns the string as is. So basically, if I call this function with a number, let's say 50, I will get back 50 pixels. And obviously, if I call this function with a string, for example 100%, I will get back the same string as a result. And the same will happen if I call this function with the string auto. So here's the question. Can you guess what is the type of the variable width in every single line of the code? And do you think this code will work as expected? So take your time, pause this video, because I will immediately reveal the answer right away. To solve this mystery, let's fire up our favorite TypeScript text editor, and it happens to have one right here. All I have to do is launch my terminal and initialize a TypeScript project. So now all I have to do is take my mouse and hover over the width parameter. So let's start from the very first line. Here TypeScript already inferred that this width parameter can be either a string, a number, or undefined. How the hell this undefined came from? Well, it turns out that since we use this question mark here, this is an optional parameter, so somebody can actually call this function without providing any value, and this will be perfectly legal. So what will happen if we go to the next line? So nothing much changes here. We have the width, which can be all these three types. The magic happens when we move the cursor to the next line, and here you will see that the width, it can be only a number. So somebody will ask, does TypeScript evaluates all this code in every single line? Does it even compile as I'm typing? Well, the answer is yes. TypeScript understood that we are within this if block. And since here we are checking if the type of the width is a number, since we are inside of the if statement, the width can be only a number, because there is nothing left for the width parameter to have as a type. So let's hover over for the one last time, and what you will see here is that width can be a string or undefined, and this is not really a good thing, because if I call this function without passing any value, the result will be actually undefined. And if I happen to use this getWidth function to display something, undefined will be displayed on screen. And that's not very helpful, isn't it? So now you will ask me, wait a minute, Nikos, do we need to hover over variables in every single line of code to know what exactly types they may have? Well, the answer is no. So a simple way to solve this is to add a type for our return value. So here, if I say, for example, that this function returns a string, then TypeScript immediately complains, saying that, this width you are returning here can be actually undefined, which is not compatible with a type string. So now let's try to fix this issue. So if you have a width property, the return value will be the width, and if you don't have, then we can have a default value, for example, auto. And I think this will fix the problem once and forever. And that's why it's a good practice to have to define types for return values. So TypeScript evaluates your code at compilation time to detect how the type of a value changes at any given position. And if you can combine this feature with type inference, then you get a pretty sophisticated error detection system. We've seen this behavior with the unknown type. So here we have a function play, which receives a list of files, but this has the type unknown. So this can be any type. We don't know what the type of the files can be. So this means that if I try to call, for example, files.map, then TypeScript will complain, saying that, object is of type unknown, so don't expect this map method to be here. So the only way for me to check if the variable has the type that I want is to use some kind of an if statement, right? And boom, the error is gone, because now TypeScript knows that files is an array, and every array has a method map. So I can freely use this in my code. For a TypeScript developer, it's important to understand how to narrow down types to more specific ones. These kind of checks are called type guards. So a type guard is a form of a code expression which helps TypeScript to refine types down to more specific types. And the purpose of this video is to actually show you all the different type guards that you have. Most of them are familiar for JavaScript developers, and TypeScript adds a little bit of a spice on top of it. Let's start with our most favorite typeof operator. Or should I say most hated? Probably the second one, but we will get into that. So, typeof operator, it's very simple. All you have to say is typeof and pass a value, and you will get back the type of this value. So in this case, it's a string. Similarly, if I say typeof 2022, it's a number. So here are all the possible return values that the typeof operator can return. So we can have undefined, we can have boolean, number, big int, string, whatever. For all the other types, basically, we will get back object. And that's not really good, because if I go here and say typeof, and I open the array brackets, I get back object. Well, as a fact, I know for sure that the array in JavaScript is indeed an object. But why, if I say typeof and I pass a function, oops, this needs parentheses, I get back a function. So there is not much logic here, right? So why on earth we don't get back array when we pass an array, and we get back a function when we pass a function? Because somebody will argue that actually functions in JavaScript are also objects. But it gets even more weird. If you say, for example, typeof null, you get back again object. That didn't go very well. Well, thankfully, TypeScript knows all this misbehavior of typeof operator, and it will warn you in case you forgot or missed something. So, +1 for having TypeScript in your projects. If you want to check if a value is an instance of a specific object, then you can actually use the instanceof operator. And we've seen it before with the play function. Here's another example that illustrates how this works. We have a function count, which accepts a list of values. This can be either an array of numbers or it can be a single number. So the result will always be a number. And if I don't check, for example, if the values is an instance of an array, then it's impossible for us to call the reduce method, because reduce method is only available for arrays but not for numbers. So that's why we check if the values parameter argument that we have here is an instance of array. And of course here you are not limited to use the built-in classes. You can basically use any class, for example track class. This will work perfectly fine. And remember that in JavaScript we have prototypical inheritance. This means that every object has a prototype, and this is what instanceof is checking. So we are checking the prototype of our object. The parent prototype of the root prototype of all the objects is the actual object. So I have another video about classes. I explain a little bit this logic. You can find it somewhere on screen. Oh wait, you cannot find it because we haven't reached 1K followers in this channel. So first, before you search this link in the description, just make sure you press this subscribe button because we need to reach 1K. And thank you very much for doing that. I bet you are familiar with if statements, so I'm not going to elaborate more on this topic. Maybe you are not familiar with the fact that in JavaScript you can have any kind of value inside the conditional. So, for example, if you have if 2022, then this is a perfectly acceptable value, and it's actually true. So what actually JavaScript is doing here is to coerce this number here to a boolean. So under the hood, the actual code will be something like this one. And then it checks this number and it understands if the value is truthy or falsy. So now you may be wondering which values are considered truthy and which values are considered falsy. And let me try to help here. Here's a list with all the values which are evaluated as falsy. So for example, if you have false, it's obviously a falsy value, right? The same applies if you have null, undefined, 0, -0, a big int 0, not a number. Yes, the result of not a number is actually false. And this also includes empty strings. Everything else evaluates to true. So if you have, for example, a truthy boolean, it is true. If you have, for example, an object or an array or a date or a number, as we've seen so far, all these values evaluate to true. If you have a string that is 0, be careful, this is also a truthy value because it's a string and it's not empty. If you have, for example, a similar string with false in it, it's also considered a truthy value because it's a string and JavaScript cannot tell if this is a string of false or not, right? The same applies with infinity, minus infinity, and with all functions that are available. So basically, the list of truthy values in JavaScript is infinite. I recommend for all of you folks who are not familiar with these concepts, spend some time, memorize all the falsy values, because once you learn those values, then you know already that everything else is truthy. Now, if you're coming from another language and you are not very familiar with JavaScript, then you should know that TypeScript also supports the ternary operator. So you can basically have a single line if-else statement. You check for a condition, and if it's truthy, then the first statement will be called. If it's falsy, then the second statement will be called. And I'm saying a statement because here you can actually put whatever you want. You can actually type full function if you want. So this will be evaluated and it will not throw any errors. Now let's go back to the previous example that we had before, our first coding challenge, and how nice we can refactor it by using a switch statement. So have a look at this code, it's just beautiful. Switch statements are very nice to be to refactor multiple if blocks. TypeScript now can be very powerful when you are using switch statements. And here's an example. So here we have actually a reducer. We have some action types, for example, loading and loaded, and we have our loading state, which currently it has only one boolean is loading, and our function reducer, which gets the current state and the action type, and according to the type it updates the state and returns the new object. So for example, if it's loading, it sets the isLoading flag to true. If it's loaded, it sets it back to false. And obviously we return the current state in any other case. So something interesting that you will probably face in your Redux applications is what if somebody add another let's say state, for example failed. How we test, how we make sure that our reducer is actually taking every single one of these action types. We can easily do that with TypeScript. There is a feature called Exhaustiveness Checking, and all we can do is have a const here. It doesn't really matter how you will name this variable. Most people call it exhaustiveness, exhaustive check or something like this. And here, the important part is that this is a type never. So never is another special type in TypeScript which should never be assigned. So this variable here should never be assigned to any value. And here, for example, if I assign the action type, then you will see a very nice error that, you know what, exhaustive check is declared with value never, but it actually gets the value string. That's not good. And I can very much solve this issue if I go here and say that, you know what, in the case of failed, you can actually return the current state as is. And yeah, now TypeScript is not complaining because it checks, it went through all the switch cases, right? Loading, loaded, failed, and this default case will never be called. It's simply never gonna happen. And that's a very nice way to test if your switch statement went through all the available cases. Good job, TypeScript. Now you're probably also familiar with the logical operators that JavaScript provides, but maybe you are not familiar what kind of values they return. So let me give you an example. Let's say, for example, we have var foo, which is some kind of a text, and we also have a var bar, which is a number 5 or whatever. So if I say foo or bar, the return value will be actually text. Yes, let me explain what happened here. So the result of the logical OR operator is to return the first value if it's true, or the second value if it's false. And in this case, they are both true, so that's why you get back the value of foo, which is the first argument. There's a very nice trick you can use in your code. For example, if you have a const tracks and you want to assign a response from a server, if this response for some reason is undefined, then you can have a fallback value with an empty array. If this logical conditional returns false, then the second value will be returned. And this is a very nice hack to use in your code. So now let's talk about the AND operator, which works a bit similar. So if we have, for example, foo and bar, then the result will be, if it's truthy, then it will be the second argument, If it's falsy, then it will be the first one or the first falsy value. So here, for example, because we have two truthy values, because this is a truthy string and this is a truthy number, as we said before, then we get back the value of the second one, which is 5. And let me give you a practical example of this. Maybe you are familiar with React and JSX. So here, for example, we have a method, a function that renders tracks. And if tracks has some kind of values, then we can map this object. If not, then this will return undefined. Another very nice trick to use in your code. So now let's talk about comparison operators. And you should know that JavaScript has had always two different ways to compare value, equality. We have the double equals and the triple equals. The double equals operator is actually implicitly coercing the values before the comparison. And just to show you how this works, if you have, for example, 5 equals string 5, then this will be true. Basically, it ignores the type of these values. This can result to very, very strange behavior, and I will strongly recommend you that you never, ever use this operator. Instead of that, you can actually use the triple equals operator, which works similar to how the double equals work in any other language. And please remember that you should always use triple equals unless you really understand what you're doing. If I say, for example, 5 triple equals 2 plus 3, this will return true. Now, if you try to compare two objects, JavaScript will always compare their references. So JavaScript will not actually compare what the contents of these objects are. We'll just simply check their references. Another thing you should be familiar is if you have not a number and you try to check if it equals with another not a number, then you will get back false, regardless if you use the double or triple equals. And that's because this is actually an object, and don't ask me why. So a good way to perform this check is to use the object is method, and then this will actually return the correct results. Of course, JavaScript supports all the other comparison operators from other programming languages. For example, you can have A smaller equals than B, and you can have whatever you want. And that's all about the comparison operators. Again, never use the double equals, always use the triple equals. In case you are curious when you have to use that double equals, then one good usage is to use it together with typeof. There are very, very limited cases when you really use this operator. So in JavaScript we have this weird feature of coercion. Basically, the language itself, it tries to cast different values for you so that you don't have to. And this is a very powerful feature, but it can have a very weird results. So we've seen this example before, how the number 5 using the double equals operator, it is equal with the string 5, and obviously the number is not equal with a string. But what JavaScript is actually doing here is to automatically convert this one of these values to the other, and it simply checks the two values, the result of this automatically coerced values. This is actually called an implicit coercion, because the language itself is doing it for you and you don't have any control over it. But there is also an explicit coercion. For example, here I can say something like number and convert this to a number, and this will basically compare two equal types. A lot of people prefer this explicit coercion because it's much more predictable. So now you will ask, if I don't do this explicit coercion, then which value is being converted actually. Is the string becoming a number or the number becoming a string? So let's actually test that, because we said that this happens everywhere in JavaScript. So if I have, for example, 5, which is a number, plus 1, which is a string, then we have a winner. So in general, there is a priority list that you should be familiar with. I will not get into more details, but string values beat everyone, number values beat strings, and something you should never do is comparing to non-primitive types, because you will always get false, because the reference, as we've seen, is being compared. Kyle Simpson said that every JavaScript developer should spend some time to understand the concept of coercion and learn its rules. And I will put a link in the description of this video if you want to learn more, and you should learn more if you start writing applications with TypeScript. There are times where you want to check if an object contains a member. And for that, it's better if you use the in operator. Basically, here we have two interfaces. One contains the play method and the other one doesn't. One is playable and the other one is unplayable. And we have a play file function which receives a file. It's either playable or unplayable. And what we can simply check in this case is if the play method is in the file object. So if we don't add this check here, TypeScript will complain because play does not exist in both of these interfaces, but this is a nice way to narrow down type members. And this one, my friends, was the last operator for today. There may be more, we can cover them in the following videos, but now, what if I tell you that with all these tools that we've learned, you can actually build your own type guards? And let me show you how this works. So we are here in the same example that we were before, and it will be nice if we can abstract this logic and have something like a function that checks if something is playable. And to do that, we can use the in operator, so we can say play in file. So far so good. What we can do is try to use this here. But you will notice that TypeScript actually complains about it. It doesn't understand, it doesn't evaluate functions that are outside the boundaries of this function, right? It will never go within this is playable, evaluate this return statement and return the type. Instead of that, is giving us a workaround. And let me show you how this works. So here in the is playable function, what we can say is that this is actually a type predicate for the file, and we are checking if the file is playable. So that's the logic behind it, and this is that you see here is a special operator that only TypeScript understands. You basically instruct TypeScript that I have this function, but this is not just any function, it also acts as a type guard, and by using this type predicate here, you basically helping TypeScript understand that this is now a type guard, and you can use it to validate if this parameter here is playable. A very powerful and useful feature. And that was it. You now know everything you need to know to narrow down the types in TypeScript. We covered a lot of concepts in this video, and I know it's hard to remember all these things, that's why I have something to offer. In my blog post about type narrowing, you can find everything I presented to you in this video, including the coding examples. It's a nice way to review what you've learned. I hope you enjoyed this episode, and if you enjoyed it, then press the thumbs up button. If you didn't like it, then press the thumbs down button. Thank you very much for watching and for supporting my channel, and don't forget to press this subscribe button because it will help a lot to grow this channel and to provide you much more useful content in the future. See you in the next one and have a creative day.